Good morning. My name is Akash Patel. First of all, I would like to thanks to Dr. Edward Palmer, and now this is a group presentation published by MEL-Group for on the connection of large renewable stations to the Australian national grid. In this presentation, we will cover the project aim, planning, what are the outcomes. We also includes NER rules that need to be satisfied by new generation and how new generation affect the stability of extended Australian national grid. In the last, we will discuss on the comparison of other forms of storage. Our aim is to investigate the construction of 350 megawatt photovoltaic farm with pump hydro storage in North Queensland. And for this, we have to satisfy our rules and Australian standard to maintain the stability of new system. And what are the market impacts of new generation? To start up this project, we had to extend Australian grid and adding 350 megawatt new power generation. And then we had to work on stability of Australian grid by checking fault investigation at point of connection. And then we have to assess harmonic and flicker and unbalanced assessment. Now, further parts will be explained by Hardik Patel.
Thank you, Akash. This slide shows the connection of 350 megawatt new generation at the point of connection, which is bus 401 and kilowatt. And for the load flow study, we are taking bus 301 Vision as a slack bus. Here we can see the load flow results after adding 350 megawatt PV generation. We get 4899.6 megawatt as a PGen and 1325 megawatt at the slack bus as a QGen. Now I will cover NER clauses that need to be satisfied for new generation. As per the NER clauses, we need to determine critical clearing time and how it is affected by new generation. As per the NER clauses, CCT doesn't has adverse effect on the new generation, and this is satisfied by in our project. As per the AEMO, system must be stable in case of frequency disturbance within a range of 47 to 52 Hz. To satisfy NER clauses, we have to work on a partially load rejection test and need to check the rate of change in frequency, and we have used MATLAB to plot the waveform of the frequency after rejecting 30% load at the point of connection. In both cases, hydro generation only and PV generation only. In case of PV generation, the frequency gets little bit higher than that in hydro generation. We also work on the voltage disturbance test, in which we have to treat the feeder between point of the connection and grid. We have done it and checked the voltage profile at every bus, and the voltage profile are within a limit of 0.9 to 1.1, which is the emergency situation. After that, we had to check the reactive power capability of the generator, and it should exceed 39.5% of the generator rating. Here we can see the graph of the terminal voltage versus time of the exciter. We have to need exciter for 5% overshoot and 5% settling time of 2 seconds. From the graph, we can calculate the settling time, which is 2.3 seconds, and as per the NER clause, it should be less than 2.5 seconds.
Thank you, Hardik. So, as he say, we are using an exciter in order to have a stable output in our system. So, if you can see in this graph, it's a machine versus angle time graph with exciter and PSS as well. So, the fifth line here, you can observe that it's really stable on our NQ gen. So, we can see that our output and our system is stable. Now, let's move on to the next topic. It's a statement on how our generation affects. So the main four factors which get affected because of the hybrid combinations of plants is first the voltage fluctuations, second frequency fluctuations, the critical clearing time, and fourth is uncertain weather conditions. Because what happened that when we are connecting a two plant, both having their different frequency and voltage, so it's really a difficult task to synchronize the frequency and voltage of both the plants in order to get a stable output. So this mean two factors, the voltage and frequency, we have to maintain when we are connecting two individual plants together in the form of hybrid. Then the third is critical clearing time, because obviously if it's a huge plant we need some time, and a plant itself needs some time to clear the fault. So sometimes it may takes more than some particular hours, so obviously it is kind of a disadvantage of a hybrid power plant. Uncertain weather condition, if you can say, it's just about solar. So if there is not enough sunlight, we are not able to generate a good like the generation will be not that much sufficient. So weather condition is the main factors when we talk about renewable energy. Now next is comparison of other form of storage. So here is the list of the things which we could use in order to increase the output of our system and in order to secure our system. So first is batteries. We can use batteries in order to store energy when there is enough sunlight, so that when due to uncertain weather condition, if there is not a proper sunlight, then we can use that stored energy and we can generate the equal amount of a generation during in uncertain condition as well. We can use the lithium batteries as well, but the main disadvantage is that we can't store energy again and again in batteries. So to overcome this we can use a capacitor instead, because capacitor is like huge rating of capacitor we can use, because we can regain it and we can energize it again and again, so it's a good thing. Otherwise we can, the third is solar, PV and wind, the two renewable sources, we can use that as well. So even though if we are talking particular about hydro and PV, even though if our hydro is not working, we can we can run our whole system on just PV. So it's a good advantage, and same as in wind and hydro. So the conclusion of our project is that our whole project is cost effective and eco-friendly, because as we are spending, how much we are spending on a coal thermal, we don't have to spend that much on renewable sources, because our output is we are taking direct input from the sources, renewable sources, and even it's eco-friendly because it's not polluting the air compared to coal, thermal, nuclear. Then it is economically and socially sustainable, the voltage will be within its limit, and we are satisfying the NER clauses in our project. The main recommendation which we can provide here is that we can use a breaker fill protection, circuit breakers, in order to secure our system and in order to give a more backup security for our protections and to our communication system. Though our project is really sustainable and fulfilling all the criteria of NER clauses. Thank you. Any questions, please?